Yeah, so today I'm going to talk about container and microservice security, particularly about Docker and so on. So before I get started, can I ask, who here has used Docker? Oh, that's not too bad. Okay, so about half the presentation is pretty high level, but later on there are some specific sort of tips and so on that are perhaps a bit more Docker specific. So you have to bear with me for those, I'm afraid. Yeah, so as Mark said, I wrote a book called Using Docker for O'Reilly Publishing. I work at a company called Container Solutions, so we do consultancy and training around containers and microservices, etc. Most of the stuff that I'm going to talk about today is also available as a free ebook, so you can go to the O'Reilly website and get more information there. If you want to get in touch with me, probably the best way is, oh, of course, can't do that, is on Twitter, Adrian Mouat. Okay, so I'm going to start off by sort of talking a bit about security and what the benefits of good security are. Then we'll look at some sort of specific container attack vectors or security problems that are perhaps more relevant to containers than VMs or other setups. We'll talk about some of the philosophy of how you should think about security. We'll have a short demo, and then sort of the second half of the presentation is more specific tips and techniques. So one of the funny things about security is that you don't really get anything for it, right? Nobody comes and gives you like a gold star or gives you a prize for having good security. It's not like when you develop a fantastic new feature and everybody comes and says, oh, you're the man, you're great, right? You do good security, nobody notices. However, security is marked by a bunch of things that don't happen, right? So what doesn't happen is your front page doesn't look like this because you've been hit by a denial of service attack because somebody's been able to exploit your code. Your front page definitely doesn't look like this because some script kiddies got in and defaced it for you. You probably don't start selling Viagra on the side, or at least I assume Tame Town Council in the UK didn't mean to start selling Viagra. You don't lose your customers' credit card details. So getting a bit more serious now, that's going to cause people misery and potentially put some companies out of business. Even more serious was this hack. So a couple of years ago now, I think, but American intelligence lost a bunch of records on military personnel, and it was also their families as well, actually. So these were people that could potentially be targeted by like criminal elements, terrorists, etc. So it put people's lives directly at risk. So this is the kind of thing you don't want to happen, and hopefully won't happen if you think about security. Okay, so now that I've motivated why you might be interested in security, just want to go through some of the sort of attack vectors you might want to think about when deploying containers. The first one is kernel attacks. So as you probably know, the difference between containers and VMs is that containers share the kernel, right? So all containers on the host will share the kernel from the host and with each other. So what that means is, for example, one container was to cause a kernel panic, it would bring down not just that container, but all the other containers and the host itself. And that kind of leads on to denial of service, because if one container consumes all the memory on the host, it'll stop not just that container, but also all the other running containers, and potentially the host itself. I guess the vector that gets talked about most is the idea of containment breakouts. So this is if an attacker gets into a container, are they able to sort of break the Docker or container security and access other containers on the host, or access the host itself? Poisoned images. So this is, are you sure that the containers that you're running have the code that you put in them, that nobody's tampered with it either in transit or at rest? And are you sure that the code's up to date? Do you trust where the code came from? Secrets also become a lot more acute with containers. So in a container setup, you've probably got dozens, hundreds, potentially thousands of containers coming and going the whole time, which is very different to when we had, a few, 2 or 3 or dozens of VMs. Because then you could manage like secrets even manually if you had to. But with lots of containers coming and going, we have to be able to like inject things like database passwords and TLS certificates automatically. So we really need an automated setup here for secrets, and that obviously has issues around how do you secure that. If you walk away with anything from this talk, it's probably the next 2 slides. So I've got this idea of security paradigms, and was it Johan that was on last? I believe he mentioned these as well. So one of them was defense in depth, and this is just the idea that you don't rely on any one layer for security. So it used to be like, 20 years ago, people always talked about the firewall, right? And people felt like if they had a firewall in place, then their organization was secure. But the issue with that approach was when anybody got past the firewall, or were perhaps already inside the firewall, then all information was open, right? So if you got past the firewall, you got everything. And defense in depth is just the idea of a multiple layers of security. So if you're past the firewall, there's still other levels of authentication and authorization. You've probably got stuff encrypted at rest, possibly using HTTPS internally as well as externally. You've probably got monitoring in place so you can see if anything funny happens. And the analogy here is with a castle. So as well as having big, thick stone walls, you've got a moat going around it. If an attacker gets past the first layer of defense, there'll still be more layers of defense inside, and they'll have to fight their way through multiple keeps before they're able to get to the crown jewels, for example. The other paradigm is the idea of least privilege. So this is just the idea that a container, or originally articulated as a process, should only have access to the data and resources that are essential to perform its function. So what that means is, for example, if I've got a front-end Node.js container, and that container doesn't need to talk to the database, not only should it not talk to the database, it should not be able to talk to the database. So it should not be able to open a network connection to the database, for example. And that way, if an attacker gets into that container, he won't be able to get to the database directly. So it's just about reducing the amount of things that a container or a process can do to the minimum that is needed for its own function. If you want to hear more about that, there was a talk by Diogo Monica and Nathan McCauley at a DockerCon called Least Privileged Microservices. So do check that out if you're interested. Ooh, demo. So this is the potential to go catastrophically wrong as usual. Okay, so I've got a simple website running in Docker, probably by the name NodeHack. You can. So I'll show it starting up. So probably by the name, you can tell something funny is going on already. Okay, so we've got this very simple website. All it does is take some YAML and prettify it. So, for example, okay, that's the idea. It just takes a YAML and sort of pretty prints it, if you like, with nice colors and highlighting. However, whoever wrote this code used an outdated version of the JavaScript YAML library. So it turns out, if our attacker comes along, they can paste YAML such as this. And as you can probably see, this looks a bit suspect already. Okay. And you're probably getting worried already, and when you click go back, you can see our website's been hacked. So just by pasting the piece of YAML, they've managed to hack the website. And that's pretty horrible. So I kind of want to pause for a second and consider what would you do if just died. I've lost my slides. Okay, so what would you do if that happened to your website? Has anybody got any suggestions? No, you're being quiet. Okay, so probably the first thing you want to do is try to isolate the sort of broken container or VM or whatever. So make sure that the attacker can no longer access it. It's probably your first move, right? Take it offline. One thing you don't want to actually do is delete the container or VM, because that container or VM or whatever contains important evidence over what happened. So don't get rid of it, because you want to be able to go and look at it later to figure out how the attacker did what they did. There's also a bunch of Docker tools and features that you can use to help you figure out what went on. So I guess I'll quickly demonstrate that. So if I do Docker, what is it? Network, disconnect, bridge. Yep. So hopefully, yeah, within the network disconnect, so that's taken our container offline so the attacker and the rest of the world can no longer access the defaced container. It's still running, so I could still run things like top to see what processes are running inside it. So we can see there's nothing too interesting there. What's perhaps more useful is I can run docker diff. And that's quite interesting, because that shows me the changes between the image that the container was created from and the running container. So that's actually immediately told us that our running container, some of these changed the index.html. So that's our defaced page. Okay. I lost my slides again. There we go. There's also a few Docker sort of features that can be used to mitigate this attack. So, and the two main ones, I guess, are running with a read-only file system, because in this case, there's no reason to be able to write to the file system, because our website is read-only, and there's nothing that goes on that needs to write to the file system. So we can run the container as read-only. We should also be running as a non-privileged user rather than as a root user, which I'll talk a little bit more about later. But let's try doing that. So we take down the old container, and we restart the container, but this time past the read-only flag. Okay, so we've restarted the container, but this read-only flag just means give it a read-only file system. So a very simple change. And our site's back up and running. This time our attacker comes along. And the attack doesn't work this time. It actually prints invalid YAML whenever there's an exception. So our front page still works. So in this case, just setting read-only, a very simple change, has allowed us to prevent this particular attack. I do want to stress, however, that this isn't a solution, right? The attacker is still able to execute arbitrary JavaScript. It's just that he can't write to the file system. So we've made the attacker's life harder by thinking about least privilege, but we have not prevented the attack. And in reality, the only way to prevent such attacks is not to run vulnerable software. Now, that's a bit of a useless thing to say, because nobody intentionally runs vulnerable software, right? So what can you do? Well, one possible approach is to use sort of modern tools like image scanners to try and automatically scan your image for known vulnerabilities. And there's a whole bunch of different solutions for this. So there's the official Docker security scanning solution. And if you go on to like the Docker Hub now, and you go and look at the official images like Redis and Debian and Alpine, you can actually click through and get a list of the security reports for each one of those. But one of the interesting things you'll find is like the base images, what people use to build their own containers from, like Debian and Red Hat, or CentOS and so on. You'll see that they all have vulnerabilities. And that's really quite annoying because it means all your images will also have vulnerabilities. Now, admittedly, those vulnerabilities probably won't affect you. Like it'll be in some particular part of the operating system that you don't use in your container. But it has the knock-on effect that you can't say, I will never put a container in production that has known vulnerability, because all your containers have known vulnerabilities. So all you can really do is get a report of the vulnerabilities and manually check if you care about those. We would much rather we could do automatically check vulnerabilities, and if there were any, stop it and not deploy. But in reality, that's just not an option. As well as the Docker security scanning, there's a bunch of other options. There's Claire from CoreOS, which is quite nice because it's free and open source, so you can start using that today. It's got an API, so you can quite easily embed it into your CI/CD system, for example. And there's a whole bunch of commercial solutions like Aqua Security, Twistlock. Red Hat have one called Atomic Scan, and NeuVector is another new one. They don't all work in quite the same way, though. So, for example, Claire from CoreOS, it figures out what software is installed in a container simply by asking the package manager. So it'll ask yum, or it'll ask apt-get for a list of software, and cross-reference that against known CVEs. Whereas Docker security scanning claims to operate at the binary level, so it'll actually scan your binaries and try and figure out what software is installed. The advantage of that approach is that it claims it can find versions of software that can install from Tarball, for example. So if you didn't install stuff with apt-get or yum, it'll still find it, hopefully. Leading on from that, you'll also find that you get specific checkers for programming languages and platforms. So there's stuff like the Node Security project will check your NPMs, for example. And that's that's an old project. That predates containers. But it's still very useful in a container world. OK, so I got some more general tips and techniques for securing things now. The first one is probably that you want to be using both containers and VMs. So sometimes people argue about like the relative security of VMs and containers, and you get security people saying, don't use containers, they're insecure. But it's a false dichotomy, because you will probably be using containers and VMs together. And by doing that, you can increase your security rather than just using containers or VMs alone. And one of the best ways you can do it is to use VMs to segregate groups of containers. So you'll place like higher security containers, for example, your containers processing credit card details in one VM, and lower security ones like your Node.js or PHP front-end containers in a different VM. And that way, if an attacker breaks into the front end, he still has a lot of work to do to get out of the VM and into the other VM doing the secure processing. And that should be relatively easy to do, especially with modern orchestrators like Kubernetes or Swarm. Last year, there was an attack or CVE called Dirty Cow. And that kind of brought this point about using VMs home, really, because that was a vulnerability found in the Linux kernel that allowed privilege escalation and could effectively be used to break out of a container. And one of the interesting effects that actually also, because it was at the kernel level, it actually also broke read-only. So like the read-only mitigation I showed you earlier, that didn't work against this attack, because this attack was at the kernel level. So the attacker could actually still write to the file system in this case. So yeah, do think about VM security as well as container security. Segregate by network. So this is slightly different to the point I just made about segregating by host. And this is just like the level of software-defined or logical networks. So in Docker, it's very easy to create networks with like Docker network create, and you've got very similar things in Kubernetes and so on. So you can create different software networks for your front end and your back end, and then your front end containers won't be able to directly talk to the back end containers, and instead you'll have like an API gateway that sits on both the networks, and that's the way the traffic will get through. Docker privileges are equal to root privileges. If you give someone access to start Docker containers on a host, they effectively have root access to that host. And it's pretty easy to think about it, because they can use a -v flag to mount any file from the host. But they can also do sneaky things like this. So one thing you can do is create a backdoor inside a container, copy it out, and then use it to become root on the host. So I'll show you that now. Let's see when this works. So I'm currently running as my user on this computer. If I run this command, we can see it's created this sh binary, and if I run this sh binary, I'm suddenly root on this machine. So if I have access to Docker, I can create a root binary that gives me root access to the host machine. So this is not running a container, this is root on the host. Yeah, I guess I'll quickly try and explain that command. So all we've done is we've created a container based on the Debian image. We've copied the file bin sh into a mounted volume, and we set the set UID bit. So it changes ownership to root and set the set UID bit. So when you run that outside, it runs as root. And that's how it works. But the key point, and if you talk to Docker, they will say this is by design, right? That's just the way Docker works at the minute. If you have access to start Docker containers, you just have root access. In the future, we'll probably start talking about unprivileged containers, but at the minute, if you have access to Docker, you have root access to that machine. User namespacing. So by default, there is no such thing as user namespacing. So namespacing is this idea that when you're in a container, you get a different view of things, right? So when I'm in a container or VM, I get my own file system that's separate to the file system on the host. I get my own view of processes. So when I type PS, I just see the processes running in the container, but I don't see the processes running in other containers. However, users are not the same. So a user in a container, like UID 0, it's the same as UID 0 on the host. Now, what that means is if your container is running as root, and a container breakout occurs, the attacker will then be root on the host, which is not a good thing. And quite simply, you wouldn't run applications in the VM as root. So why people do it in containers, I don't know. So please do not do that. However, they have started trying to add proper user namespacing to Docker. And since 1.10, I know the number in Skinny has now changed to like 1703, but for a few versions of Docker, we have had user namespacing that you can turn on. And basically what that does is map a user in a container to a high-numbered user on the host. It's got a few drawbacks, though. Firstly, you set it on a daemon, so it takes effect for all containers. So you can't set it per container, which is slightly annoying. And you then immediately run into problems like volumes, ownership of volumes, etc., because the UIDs are different. You may also find problems with like storage driver plugins, and you won't be able to use other features like PID host, net host. At one point, you couldn't use read-only file systems. I think that might have been fixed now, though. And you also won't be able to do things like make device files. Yeah, so to get around this, always make sure you set a user. And even if you're using user namespace, make sure you set a user in your Docker files. Yeah, and that's how you do it if you're interested. Be careful when deleting data in Docker files. So Docker files is how you build a Docker image. And sometimes you'll see people doing something like this. So what they're trying to do is install some software. So they've gone and downloaded it with curl, they've untarred it and they've run make to build the binary, and then they try to tidy up after themselves by removing the file. That doesn't work in Docker. Because it uses a layered file system approach, this file will still exist in the image because it existed in this layer. So what you need to do is curl, untar, and make the software and remove the file all in the same step. So it occurs in the same layer. And that does work. That will remove the file. The reason it's a security issue is because I found this code on Stack Overflow, actually. So I answered a question on Stack Overflow, and somebody had literally done this. They'd copied in the private GitHub key, downloaded the private repository, built the code, then deleted the GitHub key, and pushed the image to Docker Hub. So that meant that anybody could download their image from the Docker Hub, and he literally had this guy's private GitHub keys. Yeah, so do not do that. Set container file system to read-only. Yeah, we've seen that. So you just pass the -- read-only flag, and you can't write to the file system. And that really is quite a nice, easy way to increase security. Yeah. However, I guess a lot of applications do need to write to the file system. What you can do in that case is mount volumes for the specific files, like the temporary files or whatever, that your application needs to write to. So you're effectively poking holes in the read-only file system. Similarly, we can mount volumes as read-only. Capabilities. So are people aware of Linux kernel capabilities? Have you heard of that? Not really? Okay. So the Linux kernel basically defines capabilities, and these are things that can be attached to processes and define what kernel calls a process can make. So here, what we've done here is we've dropped the setuid capability, so this container cannot run the setuid on files inside the container and the setuid. What's more interesting is you can drop all capabilities and just add back the ones you need. CPU shares, so we can control how much CPU a container gets. However, I would recommend not touching the setting unless, one, you know what you're doing, and two, you really need it. Because by default, containers will get an equal share of CPU on the host in the event of contention. However, when you start playing with CPU shares, you can kind of break that, and it's not obvious how they work. So, do I have an example here? No. So in this example, you have to understand that CPU shares have a relative weighting, and the default weighting is 1024. So assuming these are the only 3 containers running on the host, this first one will have a relative weighting of 1024, and these two will have 512 each. So what it actually means is, in the event of contention, this one will be able to take up half the CPU, and these ones will be able to take up a quarter each. So it's not necessarily obvious how it works. And if you get it wrong, you'll end up with more trouble than if you never did it in the first place. What's much more important is setting memory limits. So by default, a Docker container can use as much memory as it likes, which does give it the potential to starve out other containers and bring down other containers to the host. So it's quite simple to set memory limits. You just pass the -m flag and how much memory you want to give the container. By default, it will also get the same amount of swap memory. So this one will actually get a gigabyte of memory in total, assuming there's swap enabled on the system. It'll get 512 megs of main memory and 512 megs of swap. Setuid and setgid binaries. So in the Docker containers, you're going to find binaries that run with elevated privileges. So things like ping and so on needs to run with higher privileges, so it can do things like create raw network sockets. However, your application probably does not need those binaries, and they're potentially a security risk because an attacker could use them to elevate the privileges. So there's no reason to be running them in production. And for example, if we have a look at the Debian Docker image, we can have a look and see what setuid binaries exist, and you find all these ones. So does anybody here know what chfn does? No? No one? So you've got a bunch of binaries that are potentially security issues in your containers, but nobody even knows what they do. I mean, in this case, it stands for change full name, so I think it edits your details in etc hosts. But there's no reason to be running that, because your application probably doesn't need it, so you can actually remove it using like a command like this. Minimal images, so this is very good for security. If you have less software in a container, you simply have less attack surface. Right? So if you look at like the Debian container, there's maybe 120 megabytes of software. But if you look at something like Alpine Linux, which is a very minimal Linux distribution, the Docker image for that is about 5 megabytes. And you compare it to the Debian at 120, it's like 115 megabytes less software. So that's 150 megabytes less lines of code that could potentially be exploited by an attacker. You can go even further though, and rather than just having a minimal Linux image, you can like create a static binary with something like Go or C, and just copy that into like a completely empty image. So your running container doesn't have anything in it apart from the binary, which is pretty cool. It does have a few issues though, because it'll be hard to debug. You won't even have like a bash shell that you can use to get in there and see what's going on. So there are pluses and minuses, but it is a pretty interesting approach, at least from a security perspective. Security modules. So there's a bunch of stuff like SE Linux and AppArmor that are what's called Linux security modules. And basically, whenever a kernel call gets made, these security modules get a chance to allow or disallow the call. There's two main ones, SE Linux and AppArmor. SE Linux was actually developed by the NSA originally, believe it or not. And it's this idea of policy-based access control or mandatory access control as opposed to discretionary access control. And basically it's to do with applying labels and contexts and making sure they match and all this. I won't go into details. The problem with it is it's a bit of a pain. It's hard to define your own policy, so I tried to like define a sort of a web server policy, and I gave up. If you're using it, you're probably going to be using like in the Red Hat ecosystem, so you'll probably be running like RHEL or CentOS, and if your storage drive for Docker is likely to be device mapper. And the first thing you'll notice is that volumes are hard to work. You have to use, oh, there it is. So the first thing you'll notice if you turn on SE Linux and you run in Docker, when you try to mount a volume, you can end up with permission denied. And unless you know what's going on, that's not an obvious error to fix. Admittedly, if you go to like the SE Linux logs, you'll see a slightly more informative message. But if you don't know to look there, you're going to be pretty confused. The answer is you've got to change the label to match the label that's applied to containers. So the chcon command, we apply that to the directory, and then suddenly we can read this file. It is a bit simpler now. You can just, rather than calling chcon, you can append a :z to the volume mount, and that'll do the same thing. AppArmor, so if you're using Debian or Ubuntu as your host, and you're running Docker, you probably will be using AppArmor, and it'll be turned on whether you've realized it or not. And by default, that will be limiting access to host files and kernel capabilities. You can pass in your own policies. Again, it's process-based. It's not as fine-grained as SE Linux, but it's still pretty useful. Again, it can be difficult to define your own policies, etc. But Jesse Frazel, who used to work at Docker, did create quite a nice project called Bane for creating your own AppArmor profiles, if you're interested. Security hardened kernels. So another thing you can do is create or use a different version of Linux kernel that's been intentionally modified for security. Basically, the most famous one is GR security. And what it does is a bunch of changes, most primarily this idea of packs, which does things to the memory. So it sets areas in memory as read-only or data-only, and also randomizes binary locations in memory and so on, which cuts out a bunch of attacks. There's always a bit of a debate about whether these changes should actually be, the normal Linux kernel. The reason these changes have not made it in to the official Linux kernel is because they add a small performance overhead. To be honest, it's not a very large performance overhead, so I would actually like to see it integrated into the standard Linux kernel, but that's not happened so far. If you do use this, the other problem you may have is that naturally these kernels do lag behind the latest version of the Linux kernel. Verifying images. So this is going back to the idea of poisoned images. You really want to know what Docker images you're running, especially in production, and where they came from. So if you're using images from the Docker Hub, if you're using like the official images, yeah, that's, they've been vetted by Docker. You're going to be pretty safe there. After the official images, you get something called automated builds, which are images that are built by the Docker Hub based on source from GitHub and so on. So you can go and see the source that they're built from, and you can check out the Docker file and see exactly what's in there. So, that's probably not bad as well, as long as you go and check them. You also have the option to build it yourself if you're worried. After that, you also get random images that people have pushed, so I would stay away from those. There's also Docker Content Trust. So if you do export Docker Content Trust equals 1, that'll do extra verification, like effectively like a GPG signature idea. So it'll check that images come from who you think it came from, etc. You can also pull by digest. So if you can pull images using like a big SHA hash, and that way you're absolutely guaranteed that you're pulling the image you think you're pulling. Auditing. So in Docker, you're generally thinking about this idea of immutable infrastructure. So with Docker containers, we don't change running containers, okay? If you need to update the software or change the version of a library, you don't run something like Ansible and change the version inside the running container. What you do is you build a new image, and you spin up a new container from that image and take down the old one. So a running container is not patched, it's replaced. And one of the nice things that comes about from that approach is we can audit the images rather than the running containers. So if I, for example, audit the software and run in one offline image, I could potentially audited like dozens or hundreds of containers. And I can verify that my running containers have not drifted from the image they were created from using tools like Docker Diff. And we also have the image scanning tools I talked about earlier. Sharing secrets. So this picture is of a cat. I think his name was Milo. Now this cat lived in London, and it turned out he kept coming home. He had a magnetic collar, and he kept coming home with all these keys and shiny things attached to his collar. And at first, the owner felt quite sorry for the cat because he was being weighed down by these keys and stuff. But it quickly turned out that the cat was going round the neighbors' gardens and digging up their keys that they'd put round the back and things. So it was nicking all these shiny things effectively, and the neighbors were not best pleased. So how do you get your secrets into your container security? So the first thing you might think about is baking your secrets into the image. So you just write them into the Docker file, like your database password or your TLS certificates, for example. Hopefully, you've all realized that's a very bad idea. Because if you put it in the image, then anybody that has access to the image has access to your secrets. So don't do that. The next way is to use environment variables. So we see here we place an API token using an environment variable, which is the -e flag. That works. It's not terrible. The reason a lot of people do it is that it was the way originally suggested by 12-factor apps, which is quite a popular methodology for building software. It's not great, though. And the reason it's not great is that environment variables can be seen in too many places. If you run docker inspect, you'll get the values of environment variables. If I run env inside a container, I'll be able to see the secrets. And that leads on to, if I'm getting support for some software I'm running in my image, then people quite often ask for the values of environment variables, so I send my support guy my environment, and suddenly I've sent the support guy all my database secrets, and that's not a good thing. Also, you can't delete environment variables. And the point I'm trying to make, they tend to get included in reports. So if you're not using environment variables, what are you doing? Well, you could use volumes. So in this case, we're just using -v to mount a file with our secrets inside. And that works. It is a bit icky, though. The main reason being that files tend to get checked into source control by accident. So it's still not a great solution. The final option is to use key value store. And this, frankly, is the future. It's maybe not quite here yet, but this will be what we're doing. So in Docker 1.13 and new versions of Docker, they did actually add secrets. So they have their own solution for this. Kubernetes also has its own solution. Do be aware, though, if you're using Kubernetes secrets, at the minute, Kubernetes stores all the secrets in etcd unencrypted. So anybody that has access to etcd and Kubernetes has access to all the secrets. I mean, that's perhaps not as bad as it first sounds, because you do need to have access to etcd, but it's certainly not great. They did think about the secrets a bit more in Docker, so that's not the case. There's also specialist software like Vault from HashiCorp that you can do the similar things with. And these key value stores tend to give you more features, such as leases, so you can say like a secret's only good for a certain amount of time, and obviously they'll take care of making sure that any secrets are stored encrypted or securely and so on. Okay, so basically, what I really want you to take away is just the idea that containers add security and isolation if used properly. So if you're using containers, you're only adding security to a system. You're not taking it away, especially if you're using it with VMs. And containers give you a whole bunch of tools and features that you can use for making attackers' lives harder, and also auditing, etc. And please, when you're thinking about security, do think about defense in depth and least privilege. Okay, that's it. Thank you for listening.
We've got time for a couple of quick questions, if there are any. Okay. Not one.
I bored you to tears, I'm sorry.
There are no questions.
Got one. No. Do you have a question? Okay.
Oh, there.
Any special thoughts on running containers in Swarm mode or Kubernetes from the security point of view? Any tips?
Any tips? I think most of the tips are largely the same. Yeah, I mean, I do have that point about like the Kubernetes secrets. So Kubernetes has its own solution for secrets, but you do need to be aware that that's not perhaps the most secure solution. Whereas Swarm actually has a better story about secrets. Other than that, I don't think I have any specific tips, no. But good question.
One more question, if there is one.
Okay.
No? Well, then let's get a big round of applause for Adrian Mouat, please. Cheers, mate.